Alright, Math Superstars, we got Polyop Day 2, joining the realm of multiplying today. So we have three methods of multiplying for our polynomials. Our one method's just like distributing, right? It's the one we're kind of used to. Our other method, we're going to be using representations for tiles. And then we got this method that we're going to be using in here. We got the box method is what we're going to call that. So three different methods: distribution, tiles, and the box. Okay, before we get into that, let's talk first about what these tiles represent right here. So right here, this big one right here, big square, it's an x squared term, right? We've got this nice legend for us here. The black part, so when it's white, it's positive. When it's filled in like this, it's negative. Okay, same thing with our x's. These are the tiles that you're familiar with from high school, that you're familiar with from middle school. So you got your x and your negative x. You've got your little unit square and then your negative unit square. Okay, so let's start off with the tiles. We'll start off with number one here. We start off by, when we're doing our product, we'll do one of our things on the one side and then the other one on the other. So one part of the product goes on the left and the other on the right. When I say one part of the product, what I mean is the 2 is one part of the product, so that would go on one side, and I'll draw it exactly how the tiles should look. 1, 2. Notice those are 2 unit tiles. Over here, this is an x, that's the other side, so that's what's going to go on this side. So I need one x tile, which will be just kind of a long one like this. Okay? So now to do the product using the tiles, we just extend the lines. Okay? All the lines, you just extend them out, and then you'll see what the result is. So here are our factors on the outside, and our product is what's on the inside. So right here, I've got 2 x's. Okay? So I've got 2 x's. Now, box method, same kind of deal. You're doing one side of the product on one side, the other product on the other side. 2 times x, 2x, right? 2 x's, 2 x's. 2 times x, 2x. All ways we've used before. Here on number 3, we got something a little different. Now we got one part of our product's x, the other part of our product's x. So this one's already drawn for us. We've got our x tile here, our x tile here. So when they extended their lines, what they found is they ended up with an x squared tile, like this one. So x times x makes an x squared. X times x makes x squared. Okay? X times x, x squared. All three methods right there. All in one. Okay, so let's put that to good use here. Let's use that down here in number 5. So right here in number 5, one part of my product, the left side, it's going to go on my left side. There's 2 x's. So I got to draw 2 x tiles. Those are my longer, skinny looking ones. And then up here, my other part of my product is a little more complicated. It's negative x plus 3. So I got 2 pieces to this. I need to draw a negative x tile. There's my negative x tile. See how it's a long one, but I filled it in. But then I need 3 unit tiles, so that's 1, 2, 3. Okay, so using my tiles here, I just extend the lines. And it doesn't matter if you go a little bit further over, they just have little lines hanging off the outside. You just kind of ignore them. Okay, so we'll just keep drawing those in, just like that. But we're not quite done here. Here's my product right here. The only problem is I have a positive times a negative. Positive times negative makes a negative. So I got to fill this guy in here. Okay, here again, positive times a negative makes this a negative. Okay, so you got to be careful what the signs are when you're doing these too. Okay. Now we're ready to actually look at what the result is. So here I've got 1 big one, 2 big ones, but they're both negative. So that's negative 2x squared. Okay. Right here I've got 1, 2, 3, 4, 5, 6 of my skinny tiles, and they're all positive, so that's plus 6x. Okay, so we got 6 of the skinny ones, 2 of the big ones. Again, when you're finding the product, make sure when you're using the tiles, this model here, you don't count the outside. Don't count your factors out here. Just count what's on the inside right here. Okay, using the box, same kind of deal here. We got 2x times negative x. Well, a negative times a positive makes a negative. The coefficients here, I got 2 times a 1, really, we have here, so that'd be 2. And then my x's, I got x times x, and just like the last problem we did, x times x makes x squared. Okay. Now here we got 3 times 2x. 3 times 2 is 6, and then there's the x here, but none here, so that's 6x. Okay, same product, right? We got the same thing here and here, just different representations. All right, let's do number 7 down here. Left side of my product, -3. So I need 1, 2, 3 of the little tiles. And they're negative, so I gotta fill them in. Okay, I gotta fill those in. Now here, this other side, I got x plus 2. So I need an x tile, and then plus 2. 1, 2. Okay. So now again, when you're using the tiles, really, it's all about, you're really just drawing. That's all you're doing, is just kind of drawing in, extending lines where you see them. Okay. Now if you'll notice, these are all negative. We have negatives times all these are positives. That makes all these negative. Okay, so we'll fill all those in, making all of them negative. And so then what we have left, 1, 2, 3 negative x's, 3 negative x's, and then I've got 1, 2, 3, 4, 5, 6 negative unit tiles. So that's 3x minus 6. And if you notice, this time we weren't given a box. We're trying to wean ourselves off it, but let's draw one in actually. Let's see if we can draw our own. If you'll notice, we got one thing, a -3, times 2 things, 2 terms. 1, 2 terms. So I need 2 pieces of the box on this side. I need an x and a 2 on this side. So if I draw my own box, each term gets its own side. Each term gets its own side length. -3 times x is -3x. -3 times 2, -6. Look at that, same result. Now looking at the back here, it says 9 through 12. We're trying to find the product without drawing tiles or using the box. Okay, so what we can do here is we can take it and we'll just do distribution. Right? Number 9 is pretty straightforward. We've seen that kind of distribution before. 3 times x is 3x. 3 times -2 is -6. Okay, that's the easy kind of distribution. Where we get a little more interesting is right here on number 11. 4x times 2x and 4x times -5. So break it down by the pieces here. 4 times 2, our coefficients, would be 8. But then x times x is x squared. X times x, always x squared. Okay? And then we can move on to the next piece. 4 times -5 would be -20. But then we've got 1x right here. We got x times, well, there's no x here, so it would just be 1x instead of that being x squared. Now for number 13, this is what we're trying to find here. It says area and perimeter. Now area, again, this is like all of it's like what's inside. So it's like trying to find like what's the product, what's inside, right? So when you think in area, we should be thinking product. Okay, perimeter, it's all outside. Okay, it's all along the outside. The perimeter is adding up all the sides. Okay, adding up all the sides is perimeter. So instead of products, we should be thinking adding. For addition. Okay, so let's do the easy one first. Perimeter. If this side is a 5x, that makes this side a 5x. If this side's a 3x, that makes this little chunk a 3x. Or sorry, not 3x, just 3. If this part of it's also a 5x, then this part also has to be a 5x. That's just being a rectangle. Okay? And then we're just adding up all the pieces. 5, 10, 15, 20. That's 20 x's. And then here we've got 3 and 3 makes 6. So it's just adding up all the sides. And that's what makes perimeter. You just add up all the sides. Now, what's inside? This is where we actually got to use what we've been doing. So that's area. We need to find what's going on the inside. And we can use the box the same way that we use the box on the other side. We have 5x here times 3. That'll give us the area of this piece. 5 times 3 is 15. X. No other x over here, so it's just the one x. Over here are two side lengths. It's a square. We got 5x times 5x. Well, 5 times 5 is 25. X times x makes x squared. So we put it all together. We got a 25x squared plus, because that's that part, plus this part, 15x. Okay. Real quick on 14, I just want to point out something. If you want to check your answers, great way to check your answers here on this unit is if you're trying some kind of product out. Let's say if you're distributing this, you use the box, you use tiles somehow, and you got this answer. How can you verify it? Well, what's nice is we can take this, plug that into y1, we'll take the other side, we'll plug that into y2 in our calculators. Unfortunately, here at home, I do not have a graphing calculator, so I can't show you. But you plug one into y1, the other one into y2. Your y2 and your y1, they need to match exactly. Okay? When they match, that tells you that they're the same thing. And that means that you verified it. That means you've made sure that this is the correct, that you've made the correct product over here. Now, your goal, using whatever methods that you can, is you have 6 problems down here on the bottom. 6 problems down here on the bottom. You're trying to multiply those out. Okay, different polynomials you're multiplying out, and you're going to be doing those on your own. So go ahead and get started on those. As just keeping it light and interesting, you get to this point in the video, like last time it was like putting a smiley face or a star by your name or something like that. I can't remember exactly what it was. This time, when you're getting started on this mixed practice, at some point when you're working on it, give Mr. P a high five. Just, make me feel good. I want 100 high fives tomorrow. And it all starts with you. All right? So, excellent work, guys. We'll see you